Tia messaged me, she'll be like 5 minutes later something.
Who? Tia. Okay.
Raheja.
Yeah. Okay. All right, let's begin. We'll just have a quick recap of what we did last time, and then we'll proceed. So we learned the Hess's law, okay, and the application of Hess's law. So we saw in the application of Hess's law, how can we find the enthalpy change of a reaction by using the enthalpy change of formation values. How to find out the enthalpy change of this reaction by using enthalpy change of formation values of the reactants and the products. Okay, so these are the products: carbon dioxide and water. In Lokaka, enthalpy change of formation value, and these are the reactants and their enthalpy change of formation values. So there are three methods by which you can find out that enthalpy change of reaction. First is we are using the formula. So this is the formula. The formula says that you need to find the enthalpy change of this full reaction. You need to add the formation enthalpy change of formation values of the products. So products may I have 3 carbon dioxide and 2 water. So these are the enthalpy change of formation values of the products. But this is for only 1 mole of the product. So 1 carbon dioxide ka minus 394 hai. So 3 carbon dioxide ka it will be minus 394 into 3. And 2 water form, so minus 286 into 2. So you will add all this, and that's like this first bracket. Okay, and then you subtract from that the total of enthalpy change of formation of products. Sorry, reactants. Reactants may I have 1 propane and 4 oxygen. So 1 propane is minus 185. Each oxygen is 0. Oxygen ka enthalpy change of formation is 0. Now, why is the enthalpy change of formation of oxygen given 0 here?
Form from his base lines, right?
Because it's an element. Okay, the enthalpy change of formation ka definition says that it's an enthalpy change when 1 mole of a substance is formed from its elements. The substance should be formed from its elements, like carbon dioxide is formed from carbon and oxygen. So that way oxygen cannot be formed from oxygen. Oxygen is oxygen by itself. So that's the reason why formation value of oxygen is 0 here. So anyways, then you add this and then subtract the minus 185. And whatever value you get, that is the enthalpy change of this reaction. That's by using the formula. So just to reinforce, if you are using the formation values to find the enthalpy change of a reaction, then you will do the products minus reactants. Okay, you will do the products minus reactants. So products ka total minus reactants का total. Okay, total of products minus total of reactants. The next method is by using the Hess'S cycle.
Sorry.
हाँ,
सर आपका कब तक है?
10 o'clock.
बीच में यार 5 मिनट इसमें मेरा डोर क्लोज है।
हाँ, अच्छा.
कितना 1 मिनट है लाइक को जब एक्चुअल डोर रेडी करेंगे।
अच्छा, ठीक है, करना है तो कर लो. हम ब्रेक. ठीक. Okay, the next method is to use a Hess'S cycle. Now we learned how to draw the cycle, which is very important. I will just do that again. The method of drawing the cycle when you are using the formation values is different than when you are using the other values. So right now we are learning how to draw the cycle, Hess'S cycle, when you have the enthalpy change of formation values. So as I said last time, in the Hess'S cycle, it's basically a triangle. So the triangle will have 3 sides and 3 corners like this. So here you write the reactants of the reaction, matlab these. And here I write the products of the reaction, which means these. Okay, and this arrow already you can see that it is pointing towards the product. So this arrow you will put here, like reactants becoming the product. Now what you need to decide is what do I write in the third corner here, and where should I put the head in this arrow and in this arrow. Okay, so these are the 3 things to be decided. So first thing, what do I write in the third corner? So for that I had said that if you are using enthalpy change of formation values, if in the question formation values are given, so you will write elements here. In the third corner, you will write elements. Now which elements? Whichever elements are producing those reactants and the products. Whichever elements are producing those reactants and products, those elements. And now arrow ka head, it will be from elements to the reactants, elements to the product, because we are using enthalpy change of formation values, and the reactants and products will be formed from their elements. So elements will form the product. So elements are reactants, and these 2 are products. So I will just write my cycle here for this particular equation. So my reactants for the equation are C3H4 plus 4O2, arrow, 3 carbon dioxide and 2 water. So that's the 2 corners on one side. Third corner I will write elements. So whichever elements will make reactants and products. So I can see that elements making the reactants are carbon, hydrogen and oxygen. I need to also balance. So C3H4 mein there are 3 carbons, H4 mein 4 hydrogens, so this, and 4 O2 here. And this very same elements will also form the products. So then I will write the arrows in these directions. So this is my cycle ready. So please note that when you are making the cycle using the formation values, third corner pe you will write the elements, and the elements, the arrows will go from the elements to the reactants and products. Now I'll fill up the values. This is the enthalpy change of reaction which I want to find out. Now this arrow, what does this arrow tell you? This arrow is forming the reactants. Reactant basically oxygen is not formed, oxygen is oxygen only, but propane is formed from the elements. So from elements to compound propane is formed. Matlab, I need this reaction actually is showing you the enthalpy change of formation of propane. And uska value given here is minus 185. So propane ka value is minus 185, so this will be minus 185. Over here, carbon, hydrogen and oxygen are forming 3 carbon dioxide and 2 water. These elements are forming 3 carbon dioxide and 2 water. So 3 carbon dioxide, which means minus 394 into 3, 2 water, which means minus 286 into 2. So this arrow ka total enthalpy will be 3 into minus 3894 plus 2 into minus 286. Okay. So I have written the values. Next, I will frame the equation to determine the enthalpy change of reaction. Now for that, I will need to look at the arrows. Everyone, please turn the video on. Next time, I will remove you from the meeting if you make me say this again and again. And next week, I will not repeat this. Next week, I will not repeat this. Every week, you make me say this. Why do you turn that but click that button? I don't understand. What is the need? What is the problem in keeping the video on? Explain me. I will allow you to keep the video off. I don't understand. Okay, now here, look at the arrows. Like this corner here has both the tails of the arrows, which means all the roots start here. And this corner has all the heads pointing towards it. Matlab all the roots end here. So all the roots start here and all the roots end here. So from start to end, this is my direct route. So this will become my indirect route. And according to Hess's cycle, Hess's law, the enthalpy change of this route is equal to enthalpy change of this route plus this plus this. So that gives me an equation that this entire thing is equal to minus 185 plus enthalpy change of reaction. Okay, so if I write that 3 into minus 394 plus 2 into minus 286 is equal to minus 185 plus enthalpy change of reaction. So now if I have to find out enthalpy change of reaction, I need to send the minus 185 on that side. So that becomes minus 185 is equal to enthalpy change of reaction. Okay, and this is the way, whatever value I calculate and get it here, that is the enthalpy change of reaction. So I'll get the same value as I obtained in the previous case when I use the formula. In fact, in the formula, I'm doing the same thing that I'm doing here. If you look at this bracket, is sum of the enthalpy change of formation of products. Okay, this. And minus, this is sum of the enthalpy change of formation of reactants, this one. And that's equal to enthalpy change of reaction. So it's the same thing that I'm doing, but the equation I'm deriving from the cycle. So you should be very fluent with drawing the cycle. What to write in each corner, where should the head of the H arrow be, and how should I frame the equation on the basis of that. One second, start kar rahe ho abhi? Huh? Okay, we'll take a 1 minute break.
So can we keep our videos off during the break?
Yes, you can. Right. Videos on again. Okay, the last method, the third method was manipulating the equations to get the enthalpy change. How do you work in this? Again, this is the equation whose enthalpy change you want to find out. And these are the three equations which are given in the question, and their enthalpy change values are also provided. This questions, like this manipulation, this method often comes in the MCQs. So you have to be very quick in calculations and arriving at the answer. Okay. Okay, so how do you manipulate and how do you decide what is the enthalpy change of this? Basically, this is my target equation. Okay, and these are the equations which I need to manipulate. And manipulate in such a way that when I add these three equations, they should add and give me this equation. Okay, when I add these three equations, the manipulated equations, I should get this equation. And how do I manipulate then? I look at each substance in that equation. Let's say I start with propine. Okay. So in the target equation, I want 1 mole of propine, and on the left hand side. Okay. So you will look at target equation and see what do you want in the equation, how many moles, and which side, which substance, how many moles, and which side. So I start with propine, 1 mole, left hand side. Okay. Out of these three equations, which equation has a propine in it?
Third one.
Third one. Is it 1 mole?
Sir, but it's a gas. Does that matter?
Yeah, I know. Actually, this should be gas. That's a mistake. This should be gas. Okay. Is that 1 mole? That propine in the third equation?
Yeah.
Yeah. Is it on the left hand side? No. So I have a 1 mole of propine here, but it's like number of moles is correct, but it's on the wrong side, which means I need to shift that on the left hand side as required by the equation. As required in the equation, I need to shift that to the left hand side. So what I will do is that I will switch the products and the reactants. Reactants and products will be switched, which means I'm inverting the entire reaction. Reactants become product and products become reactant. So when I'm doing that, the enthalpy change of value will also get inverted, which means minus 185 ki jagah pe it will be plus 185, because minus 185 was the value for the forward reaction. Now I'm considering the backward reaction and I'm considering the reverse reaction. Okay, so this became 185. So I manipulated the equation and I manipulated the enthalpy change accordingly. So this is done. Next, after propine, I look at oxygen. So I want 4 moles oxygen left hand side. So which equation have oxygen here? Nobody wants to answer?
The first
Nobody
one.
wants to open their mouth and take some trouble and answer the question? Everybody unmute yourself. Are you all hearing me? Vedant, Alia, Saina? Did you hear me when I said unmute yourself?
Yes, sir.
Then I want everybody to open their mouth and answer, okay? Saina, you didn't hear me.
So I heard you.
But you didn't keep yourself unmuted then. Why are you keeping yourself?
Oh,
Do you
sorry, I
understand?
have every time I speak, I mute myself.
What do you mean
Sorry.
by keep unmuted?
Yeah.
Temporarily. Okay. Okay, so which reaction here has oxygen?
First and second.
First and second.
Everybody didn't answer.
First and second.
First and second.
Akhil didn't answer. Mahir
and
didn't
second.
answer. Vedant didn't speak anything.
So when I said first and second.
So which Vedant are you talking about?
Gedela. Okay, so first and second. So remember, whenever any substance in the target equation, वापस करना है? हाँ, कर. Target equation is appearing in more than one equation. Ignore that. Okay, just ignore that. आप कर लो. So ignore oxygen because it's appearing in more than one equation. So I'll look at the next one. And you know that this equation I have already manipulated. Next is 3 moles carbon dioxide, right hand side. So I have carbon dioxide here, right hand side, but only 1 mole. So what should I do here?
Nothing. Like you don't change anything.
Nothing.
Multiply by 3.
Yeah, you multiply by
Yes,
3. Yeah.
3
Sorry.
moles hai na idhar.
Yeah.
Please do look at, that's what I said, that you should look at which substance, which side and how many moles, everything. Okay, which means I should multiply this equation by 3. So I will multiply its enthalpy change also by 3. Okay, enthalpy value also by 3. Next, 2 moles water.
So don't you make it positive last 3 and 4?
Why?
Wait. Sorry. Yeah.
I'm not switching the side. It's on the right
Yeah.
and the correct side.
Yeah,
Okay.
got it.
Now here, 2 moles water right hand side. Here I have 1 mole water right hand side. So I need to make this 2. Matlab multiply and the entire equation by 2. So multiply this also by 2. Okay. So I took manipulation decision for every reaction. Now all I need to do is that add the reactions. So when I add these reactions now, it will add up to this. So what about enthalpy change? Of course, the added reactions ka enthalpy change also should be added to get the enthalpy change of this reaction. So I will add all these. Minus 394 into 3 plus minus 286 into 2 and plus 185. Okay, this is how you will do the manipulation part. Anybody is not clear about anything in the manipulation? Because this is very frequently asked questions in the MCQ. So will everyone be able to manipulate and get the answer?
Yes.
Yes, sir.
Yes.
Yes.
Okay. Okay, now we have seen 3 methods to find out the enthalpy change when we use the enthalpy change of formation value. Now we'll do the exact same thing for the enthalpy change of combustion values. Earlier we used enthalpy change of formation values. Now we are using enthalpy change of combustion values. But before that, we need to understand the definition of the enthalpy change of combustion. So enthalpy change of a combustion of a substance is enthalpy change when something is burning, something is getting combusted. But as we know, we noticed the keywords in the formation. There are keywords here also which you must note, that 1 mole of substance must be combusted. 1 mole. Okay, and completely. And it should be in the standard state and under standard conditions. Okay, so 1 mole of substance is burned. That is most important keyword. Okay, and standard state and standard conditions. So 1 mole, remember this, 1 mole of substance should be burned. So out of these 3 reactions, which reaction can I reject for the enthalpy change of combustion of propanol? The first reaction, what do you think? Is that correct according to the enthalpy change of combustion definition?
Yes, sir.
Yes, sir.
No, propanol is a liquid. Okay. Second one?
Yeah.
Yeah, sir.
Yes. Third one, may what is the problem?
It's
2 more.
2 more.
2 more.
So I need to divide this by equation by 2. Okay. Okay, now after understanding the enthalpy change of combustion, we will use the same 3 methods: formula, triangle, and manipulation. using the formula, using the manipulation, and using the Hess'S triangle, Hess'S cycle, to find the enthalpy change of a particular reaction. So let's start. The processes are same. Okay, but only slight change in the cycle. Also in formula where there is one small change. First, the formula. Everyone, please pay attention here. Now, how do I find out the enthalpy change of reaction from enthalpy change of combustion value? So I didn't write the reaction value. Reaction is six carbon plus 3 hydrogen gives you benzene. And I need to find the enthalpy change of this reaction. First, by using the formula. When I use the enthalpy change of formation values, my formula was sum of enthalpy change of formation values of products minus sum of enthalpy change of formation values of reactants. Okay, so when I'm using the formation values, I'm adding the products ka formation values and subtracting from that the reactants ka formation values. But when I'm using the enthalpy change of combustion values, enthalpy change of combustion values when I'm using, only different thing I will do is that instead of reactants here, I will do the products and products ki jagah pe reactant. Matlab here I will do reactants minus products. Okay, hope everybody understood. And of course, the formation value will become the combustion values. So when I'm using formation values, I did products minus reactants. When I'm using combustion values, I'll do reactant minus products. Any problem?
So, but why do you interchange them?
We'll see that in the next part. Okay, we'll see that in the next part. So hope everybody will remember that whenever you're using combustion values, so total of reactant minus total of products. And formation values are the total of products minus total of reactants. Okay, so let's solve this one. 6 carbons, carbon, but 1 carbon hai. So minus 394 into 6. I'm adding the sum of the enthalpies of combustion of reactants. So 6 into minus 394 plus 3 hydrogen Ba. So 3 into minus 286. This is the sum of the enthalpy change of reactants. Minus products में 1 mole of benzene है. So that's minus 3267. Okay, is anybody any problem?
No, sir.
So the answer here is plus 45. Okay, kilojoule is the answer for this reaction. Okay, enthalpy change of this reaction is plus 45. Okay, this is by using the formula. Okay, so formula done. Now we'll go to the cycle. How do you draw the cycle for this? Again, the cycle ka same thing. It's a triangle. Here you write reactants of the reaction, which is 6 carbon plus 3 hydrogen. Here you write the products, which is benzene, and the arrow in this direction as given in the main equation. Now again the question, what should I write in the third corner? So listen to this carefully again. When you are using combustion values, the third corner will be products of combustion. Third corner will be products of combustion. Whose combustion? Of the reactants and the products. Okay, so let's look at the reactant. Reactant may have 6 carbon. So when carbon burns, what is produced?
Carbon dioxide.
Carbon dioxide. When hydrogen is burnt, what is produced?
Water.
Water. Okay, but 6 carbons hai to 6 carbon dioxide, 3 water, 3 hydrogen hai to 3 water. When benzene is burnt, what do you get?
Same thing.
Same thing. 6 carbon dioxide and 3 water. Okay. So, okay, that's fine. When formation values use hota hai to third corner mein what do you write?
Your elements.
Elements. And agar combustion values hai to third corner mein you'll write the products of combustion of reactants and products. Okay. Now the direction of the arrow. We're talking about combustion values. So combustion mein reactants will burn to give the products of combustion. Products will burn to give the products of combustion. Okay. As we are calling them products of combustion of these guys and these guys. So of course, the arrow should be pointed towards the product. Note that in the formation, the arrow was in the opposite side, because this was elements and they were the compounds. So elements are forming compounds. So the arrow was in the opposite side in case of formation. Okay, is anyone having any problem? Anything not understood before I go ahead?
No, understood.
Okay, now I'll label the arrows. This is enthalpy change of reaction, which I want to find out. This arrow here is combustion of benzene. Benzene is burning. One more thing I forgot, that you need to balance. I think you can write oxygen, whatever number of moles of oxygen here on both the sides, because oxygen is something that is missing on this side. Okay. That balancing you can do of oxygen. It will be 6, 12, 12 plus 15, so 7.5. So 7.5 oxygen here and 7.5 oxygen here. Okay. So here this side is saying that combustion of benzene hai. So benzene ka combustion is minus 3267. This is the value for this arrow. Enthalpy change of this reaction. Enthalpy change of this reaction mein I am burning 6 carbon and 3 hydrogen. 6 carbons and 3 hydrogen. 1 carbon burning ka minus 394 hai. So 6 into minus 394 plus 3 hydrogen. So 3 into minus 286. So I have labeled all the arrows. Now it's time to frame the equation. Equation I will check the initial point of all the roots and final point of all the roots. So initial may both the tails here and both the heads here. Matlab from here to here is direct route, and this will become your indirect route. So according to Hess'S cycle, iska enthalpy change matlab this is equal to this plus this. So I'll just write the equation here. Six minus 394 plus 3 minus 286 is equal to enthalpy change of reaction plus minus 3267. Okay. Now I need to find out this. Of course, this I will send on the other side. So my reaction equation will be this minus 3267 is equal to enthalpy change of reaction. Okay, is this okay? Anybody has any issues in this? Do you not understand any part? Okay, now somebody had asked that why in the...
Isn't this just the same as the previous thing?
No, it is not the same. Now somebody asked that why when you're using combustion values, why do you do reactant minus products instead of products minus reactant? Now, if you actually see this value, aren't these values here sum of or addition of enthalpy change of formation of reactants, 6 carbon and 3 hydrogen? Isn't it that? So isn't this sum of enthalpy change of combustion of reactants? And this is minus. Isn't this the sum of the enthalpy change of combustion of product?
Yes, sir.
Which is equal to enthalpy change of reaction. All right. So that's the reason why we have derived the equation from or formula from the cycle only. Obviously, see, earlier case may the direction of the arrow was different, na, in the previous cycle. Okay, everyone.
Yes, sir.
Remember that agar combustion values hai, the third corner will be products of combustion and arrows will be towards it. Formation values hai, the third corner will be elements and arrows will go away from it. Okay, and then you can also figure out the equation using the direction of the arrows. So basically, reactants, products and elements formation values अगर है तो ये ऐसे होता है. Okay, and reactants, products and products of combustion it will be here. And in both the cases, I will need to find out this enthalpy change of this reaction, enthalpy change of this reaction. So let's say this is X and this is Y. This is X and this is Y. So according to the directions of the arrows, delta HR here will be Y minus X, like this minus this. And here, enthalpy change of reaction will be X minus Y. You can see? So Y minus X matlab products, Y is for the products, no? X is for the reactant. So products minus reactants. And here, X is for the reactant, Y is for the product. So reactant minus product. The third one is manipulation, which is ditto same. Exactly same thing that we did in the previous case. So this is the reaction that I need. So here I want 6 carbon left hand side. So here I need to multiply this by 6. So multiply this also by 6. Okay, 6 carbon left hand side, 6 carbon left hand side. 3 hydrogen left hand side. So multiply this equation by 3. So multiply the enthalpy change also by 3. Benzene, 1 benzene right hand side. Here I have 1 benzene left hand side. So I'll switch the equations, the sides. So this will become plus 3267. Now to find the enthalpy change of this reaction, just add up the enthalpy these change. This will also give you plus 45. Okay, same as the what answer you got in the first and the second method. Okay, so manipulation is exactly same. Everybody will solve these questions now. Now, today SL part is over. We just have one last topic here. All these questions you can solve. These are all manipulation methods. Okay. The last part of the SL topic is bond enthalpies. Now, what do you mean by bond enthalpy? Bond enthalpy is also called as bond energy. Bond energy for a particular bond, and it has to be a covalent bond. Huh? It has to be a covalent bond. It shows how strong the bond is, which means how much energy will be required to break that bond. Okay, to break that bond. But here again, there are keywords. Break only 1 mole of bond. And in the gaseous molecule, this is a very important keyword, gaseous molecule. Okay, so I have to break 1 mole of bonds in the gaseous molecule, and how much energy is required to break that? That much energy is called as bond enthalpy of that bond. For example, HH bond. To break this 1 mole of this bond, I will require 436 kilojoules of energy. Okay. So accordingly, which is the strongest bond in the table?
HF.
Hydrogen.
HF is the strongest, and which is the weakest?
Yeah.
Yes, yeah.
ClCl is the weakest. Okay. But please remember the keywords in the definition, because according to definition, we'll be able to decide the reaction or equation. 1 mole should be broken, and molecule must be in the gaseous form. Okay. What does it mean by gaseous molecule? For example, suppose if I have to break the OH bond, so in which compound will I get this OH bond? Do you know any compound in which there is OH bond? O single bond H?
H2O.
H2O, water में है. Okay. So water में है. But what is the state of the water? Standard state?
Liquid.
Liquid. Okay. So this definition will not allow you to break the OH bond in the liquid water. So this water should be also in the gaseous state. Okay.
But that
That's the reason
doesn't-
it is standard condition, but not standard state. Standard condition, but not standard state. Understand that in the enthalpy change of combustion definition, they said both. Hope you remember. The substance that is burning must be in the standard state. Like ethanol burn kar rahe ho, so it should be in liquid. Agar butane burn kar rahe ho, so it should be in the gas. But here, the standard state is not allowed. It is forcing the molecule to be in the gaseous. Conditions must be standard, but the substance जिसमें का bond you are breaking must be in the gaseous molecule. So it is not allowing you liquid, solid, and aqueous states. Okay, now next thing. In which molecule will you find this HH bond? If I have to break the HH bond, which molecule will have that? H, single bond H.
H2O. I mean H2. H2.
Hydrogen.
Hydrogen.
Okay. Yeah, give me one more example. One more molecule in which there is HH bond.
So that's it, no?
That's it. You will not have this bond in any other molecule in the entire universe. Why? Because when hydrogen is bonded to another hydrogen, can each hydrogen bond to anything else?
No.
No, that's it. Okay, which molecules will have ClCl bond?
Cl2.
Only chlorine. HCl, only
Yes.
hydrogen chloride. Okay, so all these bonds that are given here, remember that these bonds are found in that specific example molecule only. Okay, and no other molecule will have that particular bond. Now, whenever you are talking about the bond enthalpy of such bonds, you will call it as bond enthalpy. Does that make sense? How does that make sense? How does that make sense? I said, whenever you are talking about the bond enthalpy of such bonds, you will call it as bond enthalpy. So I said bond enthalpy only. No? So what else can I call? The other word is average bond enthalpy. Okay. As other word is average bond enthalpy. For these molecules, you cannot use the word average because that's the only molecules in which they are found. Okay, but then which molecules will be average? I just took one example of OH. And which molecule you said will have OH bond in it?
H2O.
Any more?
Yes.
COOH.
All the alcohols will have, like
All
methanol, propanol, right? Like
all
CH,
carboxylic acids.
all carboxylic acids will have. Okay, R, COOH will have. Hydrogen peroxide will have. HOOH, right? And remember that in every example, the OH bond present in it will be differently strong. So can I say that OH bond ka bond enthalpy is different depending on which molecule has that OH bond? Is that correct? Depending on which molecule I am breaking that bond, if the molecule changes, the bond enthalpy value will also change. But OH bond can be found in say thousands of molecules. I cannot have 1000 values in my data booklet. Say कि OH है तो OH in water is different, OH in alcohol is different, OH in which one? That I cannot have. So what data booklet does is that data booklet shows you the average value. Okay, so whichever bond can be found in more than one compound, we will use the word average bond enthalpy for those bond enthalpy. That will not be the absolute bond enthalpy, that will be the average bond enthalpy. Anybody is not clear about the average word? Saina, you are tensed.
No, so I'm understanding.
You're understanding? Okay, fine. Good. Okay. So even the definition of the average bond enthalpy will be different. Huh? Like this definition, what we learned here is for the bond enthalpy. Okay. When the question says average bond enthalpy, please do not write this definition. So average bond enthalpy ka definition idhar hai. It's exactly the same thing. Like from here till here, it is same thing as bond enthalpy. Only thing is that you add this phrase averaged over similar compounds. Whenever the word average is included in the definition question, you include this phrase in your answer. Okay? Otherwise, you lose 1 mark here. Okay, so hope everybody is okay about this. I'm going ahead. Definition, may please take care of the noticing that the word average is there or not there. Okay, like these are the average bond enthalpies of those bonds. Okay, so now how do I and where do I use this? Okay, IGCSE students, we have already done this in the 10th grade. This is again used to find the enthalpy change of a reaction. Enthalpy change of a reaction. Okay, now suppose reaction is A plus B gives you C plus D. Reactants and products. Reactants molecules will have some bonds. Reactant molecules will have some bonds. Add up the bond enthalpies of all of them. Come to the products. Products molecules will also have some bonds. Add up the bond enthalpy of every bond and then just subtract them. So here, अभी करना है क्योंकि वो अभी we don't know ना when will it start. So that's the reason I'm not even trying to decide that how the entire thing will be, and because later on what if something else comes in and again वो तोड़फोड़ हो जाएगी. So better that's what I'm just when I'm here I'm just thinking about and keeping my mind, but let the idea develop and then one final thing. Nothing important, nothing urgent as such. Yeah. Only things books are here. नहीं. I think that's only A level का एक batch रहेगा. They will come here, but that is only one class. Yeah. That's only one class.
बुक्स रखने के लिए एक एल्विरा एक किचन में पड़ी हुई है, उसमें भी डाल सकते हो.
हाँ. So if you just something bring.
तो वहाँ बॉक्सेस भी अभी पड़ा है, खाली वहाँ भी अगर डंप करनी.
नहीं dump नहीं करना है. I may need this.
You need it.
हाँ, I may need this anytime. So yeah.
तो फिर अगर वो लगा है तो वो भी लगा सकते हो.
But don't put racks. मतलब कुछ खिला वगैरह अगर अलमीरा रख के रखनी है तो अलग बात है.
एक स्टील अलमीरा है, उसको खाली किया जा सकता है.
So if it is unused, so fine. हाँ तो फिर ये काफी हट जाएगी, सब अंदर चला जाएगा। ठीक है, या दैट आई विल, या थैंक यू। Okay. All right, so we'll take one example of combustion of methane. So methane has 4 CH bonds in it, and CH bond ka bond enthalpy, all these values are you can take from the data booklet. So plus 413. So I need to break 4 CH bonds. Remember that bonds in the reactants are broken and bonds in the products are formed. So here energy is taken in, here energy is given out. That's the reason why when I'm talking about the reactants, I'm saying bond broken and energy taken in. So 4 CH bonds plus 1652 and 2 oxygen molecules में 2 OO bonds plus 996. So total plus 2648. So plus 2648 is total energy required to break all the bonds in the reactant. So plus 2648. Now how much energy is given out when the bonds are formed? That calculation is also given down. So 2 C double bond O formed and 4 of the OH bond formed. So total 3464. Okay, so 6464 is greater than 2648. So more energy given out. Energy given out is more than energy taken in. So it's an exothermic reaction. But we wanted to find the delta H. So delta H may, remember delta H of the reaction, you'll always do the bond enthalpies of reactants minus bond enthalpies of products. So here is reactant minus products. Okay? अगर bond enthalpies use कर रहे हैं तो reactant minus products. So whatever the answer you get, that is. Okay. So we learned 3 things. If you're using bond enthalpy change of formation, so you will enthalpy change of formation values अगर है तो you will do products minus reactants. Enthalpy change of combustion values है तो reactants minus products. And bond enthalpies, the average bond enthalpy values है तो reactants minus products. Okay. So SL students, these are the 3 things that you need to remember. HL students, more such reactant minus products minus reactants coming in the HL portion. So SL is sorted here. Okay, the next part is about the ozone. This error thing I will explain, and then ozone ka, if the school teacher teaches you, let me know. Okay, and HL students, we have already done this in the HL bonding part. Exactly same thing. Okay, the bond enthalpies of this. In fact, you have done more than this. You have done about those CFCs also, the catalytic destruction of ozone, that SL does not have. Okay, so often, the question comes like, they will ask you to find the enthalpy change of reaction by using bond enthalpy values. Bond enthalpy values are given in table 11. But in the old data booklet, it was in table 10. Old data booklet, it was in table 10. So in the question bank, you will see table 10. But you will not look into table 10. You look into table 11. I hope everybody is listening to me.
Yes, sir.
Yes, sir.
Old data booklet, the bond enthalpy values are given in 10. New data booklet 11. So when you solve the question bank, the question will mention refer to the table 10, but you will not look into table 10, you will look into the table 11. Another common question, they will ask you to find the enthalpy change of reaction by using the table 11. And they're saying that why is this value inaccurate? Okay, why is this value inaccurate? So there are 2 typical answers to that. 2 typical answers to that. One, you will say that the bond enthalpies are average bond enthalpies and not the absolute bond enthalpy is for that specific bond in that specific molecule. For example, here, if suppose if I'm saying CH value is plus 413, I'm using 413 for CH in the methane. But specifically methane ka value can be something else. Na? 413 is the average value of so many hydrocarbons and so many compounds. But specifically methane ka value, CH in the methane may be something else. But I'm not using the exact correct value for the CH bond in the methane. I'm using the average value. Is everybody understanding about this? Everybody getting this, what I'm saying? Okay,
Yeah.
that's one thing you can say. Second thing, if I'm referring to the OH bond is how much? Oh, okay, whatever. Suppose 468. OH bond is, let's say, 468. But OH bond in the equation, this OH bond is in the water, which is liquid. Okay, but bond enthalpy definition says what? The molecule must be in the gaseous form. Okay, so that is another typical blame or reasoning that you can give. Okay, that the compound is not in the gaseous form. It's in the liquid form or solid form or whatever. Okay, these are the two typical reasons you will give why the value is inaccurate. So here the water will be in the liquid state. So that is one problem. And water ka jo values, OH values that I'm taking is all assuming that it's in the gaseous form. But water is not in the gaseous form in my reaction. In my reaction, it's in the liquid form. Okay. So let's see what else. So that's it. Energy profile diagram we have done already. Okay, ozone will do when in case of teacher does. Yeah, otherwise there are.
So I don't
Yeah.
know the energy profile diagram. Like I don't know.
We had done this in the beginning of the chapter. First class you had attended.
Yeah, so by like in
Activate
a
energy part.
Yeah, okay. See, this is the exothermic reaction. So exothermic reaction may energy is given out. Okay, when energy is given out, matlab final energy is lower than the initial. Okay, initial is higher, na energy, and final is lower. Okay, and this is the drop. This is the drop in the enthalpy, which is enthalpy change delta H, which is downward arrow. That's activation energy, which will be asked mostly in the 6th chapter. So that's exothermic reaction. The only thing is that here, there in the initial part of the chapter, it was written as enthalpy, or here it is written as potential energy. The next graph is for endothermic reactions, because endothermic reaction where energy is gained. So final energy is greater than initial. So initial was this much, final is this much. So this much is the increase. So that's my delta H. And that's the activation energy. Okay, that's all.
yes, I got it.
That's it. So, all right. So we are done with SL, energetics. SL students will start solving the questions. HL students will not wait. You will also start solving the questions. Okay. But next week I'll continue with HL portion. Has the school started HL energetics? Oh yeah, they're about to finish now.
Yeah, so she's taking a test on 18th.
Then Tuja has finished like
18.
2 classes ago.
Okay, fine. Okay, I will need 2 classes for HL portion. 2 classes I can finish.
Okay, sir.
And so at least start the SL portion. SL portion, I'm telling you, typical questions coming. So even if you solve like 5 questions of each type, done, you're done. Like how to find the enthalpy change using formation values, combustion values, bond enthalpy, reason why values are inaccurate. Okay, and this typical questions are repeatedly asked. The values change, the compound change. But just get used to it. Don't wait for the one day before the test. Okay, start the work. So I'll see you next week. Bye.
Bye,
Bye,
sir.
sir.
Thank
So how
Bye,
do
sir.
we